I5Y science passage number 1. Kids, it's practice problem number 1. You'll notice practice problem number 1 is long. It's 4 lines of text. I always read the last part of the question, which is in yellow here. It says, which of the following was the most likely magnification of the images? Then go back in, underline what's important. It says experiment 1, 52%. All right, then what we do is we go to experiment number 1. You'll notice that experiment number 1 deals with this stuff up here. We're looking for magnification. You see that magnification comes from both of these particular areas here, and then we're looking for the compression rate. All right, so if you glance at the answer choices, you see that in the answer choices it has 1x, 4x, 10x. That's going to lead you up here for this little key right here, and then basically what you're looking for is you're looking on the first day at 52%. So here's day 1, go up to 52%. You see it's the dotted line that's going to give you 4x. The correct answer here is answer choice B. Practice problem number 2, it's point, and then we're going to go ahead and estimate. All right, we're doing an additional trial here for experiment number 2 using the 4th compression rate. So what we want to do is we want to go up and take a look at experiment number 2. Here it is right here, experiment 2, and you're going to notice that this is where we're going to get the figure 3. We're going to get the info from this. Okay, here you see that in green I have the compression rate, and what we're looking for is we're looking for a 4th new compression rate at 21.1. So that's going to roughly be right in the middle, right over here. So we're going to estimate when we look at figure number 3. When we do that, we're going to see that it's going to come in between the 70% and 80%. That's going to give you answer choice G over here on that one for practice problem. Problem number 3, we're looking for the difference between experiment 1 and experiment 2. You're going to notice that we've got our pirate flags right over here. You see that we have the word in blue instead and except right over here. That's going to lead you down a little bit further, and it tells you here they're differently reinforced right over here. That's going to give you answer choice D for practice problem number 3. Pirate flags, kids. Practice problem number 4, tricky. It's a long question. Make sure that you start by reading the question itself. I have it here highlighted in yellow. Here's what the question is asking you, so read it first. According to figure 2, are the results from experiment 1 consistent with the prediction? So experiment 1, if you look over here, experiment 1 is talking about pigeons being trained to differentiate images and find cancer cells. They're looking at different various magnifications and rotations. Okay, now the trap on this test here, if you look at the question, we're looking at figure 2, so you have to make sure that you look at figure 2. Figure 2 is down here, so we're looking, does the magnification help you differentiate, yes or no? So here it is here, it's 4, it's 10, and you're looking at 20. So if you look over here, you start high, and then it comes down lower. You see how this is lower, and then it comes back up higher. So the answer on this one is going to be no. We can cross out the yeses here, and that leaves us with answer choice H and answer choice J. Now, what's the one difference between the two? Answer choice H talks about the 15 different days, and answer choice J talks about the different magnifications, 4, 10, and 20. J is the correct answer. A, make sure that you look at the right area. Figure 2 is coming from down over here. All right, that's the trap on the test, and you're going to notice that the question is super long, so if you start reading from the top, you're not going to understand what the question is. Start by reading the question first, then adding in the information after you already understand. My recommendation is read the question first, then glance over at figure 2, and then read this additional information after. Long question, if you're getting it wrong, this is called a long question stem. Practice problem number 5 is a yikes problem. What we're going to do is we're going to finger scan for the answer choices when we come in here. Practice problem 5A, we're looking here for what's constant in experiment 1 and experiment 2. So if you look at answer choice A and B, we're looking for compression rates and reinforcement. If you come back over here and see in the pink on line 3 in experiment 1, here it says various magnifications and rotations. That means answer choice A and B both, boom, can be knocked out. Now we're left with answer choice C and answer choice D. What I did is I converted over to take a look at experiment number 2. When I came over here to experiment number 2, I saw on line 3 it says different compression rates. Then I read down a little bit further and I found over here it says half were differentially reinforced. So that means we can cross out those answer choices here, which deal with answer choice D. C is going to be the correct answer, kids, for problem number 5. On to practice problem number 6, kids. It's a long question. First thing that you want to do is make sure that you read the question at the bottom. The bottom, I have it highlighted here in yellow. It says, which of the following modifications would best help eliminate this problem? So what's the problem? If you look up here, I just underlined, it said entry and exit into the lab. So we're going to disturb the pigeons, all right? What I did next, once I understand I'm trying to eliminate the problem of entering the laboratory and disrupting the pigeons, I quickly glanced at the answer choices down there. I saw in answer choice F, it says the volume of the continuous white noise, the number of images, and then I realized it's a yikes problem. I came up here and I started looking in area of the text. I found in the green area here on line 4, it says various magnifications and rotations. They were trained in a closed chamber with continuous white noise. If we're going to disrupt the pigeons, what we do is we just simply increase the volume of the white noise. That's going to leave you with answer choice F. It's a yikes problem, kids, problem 6. Kids, and finally, it's problem number 7. It's the dreaded prior knowledge question. It's a biological question dealing with taxonomic domains. Here is an awesome chart that I pulled up off of the internet that will explain things quite easily. The question here for 7, pigeons belong to which taxonomic domains? All right, so if you think of a giant root, you're going to see that the root has different branches. So here we have in the main part of the root, eukaryota, and then above we have the archaea, and then below we have the bacteria. All right, let's start with the bacteria. Bacteria, it's real easy. It's simply just germs. On the top, archaea. Archaea is the root word for archaeology, the study of ancient stuff. So what is archaea? Archaea is something that's super, super, super old. An example of this is something called methogens. Methogens are single-celled organisms that are found in the deep sea thermal trenches. Origin of life has been suggested that we started inside these deep sea thermal vents. These small little single-celled organisms can live in degrees up to thousands of degrees in the heat. Here in the middle, you're going to see the eukaryota, and the eukaryota has 3 sub-branches. The first sub-branch here is fungus, like mushrooms. Then we have animals, and then we have plants. Well, obviously, a bird is going to be an animal, so you just simply trace it on down. If you'd like to keep this particular chart for future reference, go ahead and just simply take a picture with your cam right now of this awesome chart. So problem number 7 leads us to answer choice C. All right, it's problem number 8, kids. Point. Underline what's important and then just get there. Here is the problem according to figure 2. We'll underline that. Which of the following highest delta squared H values measured along all butterflies is studied. All right, so let's simply go and find figure 2. It's down over here. Then what we want to do is find the highest delta squared H. That's going to be over here on the y-axis. And now we're going to see the highest value is up here at 160. So just simply look at this green line here. It's roughly 155 or so. When you look at your answer choices, F pops off the page. Boom. Kids, it's on to problem number 9. It says, according to the line that fits figure 2, as wing area increases, delta squared H equals what? We're going to simply just point, underline what's important over here. You see we're looking for figure 2. Figure 2 is down over here. We're looking for delta squared H. That's going to come from the y-axis over here. And as it increases, what happens to the wing area? The wing area is here. So it's basically this pink line. As we increase X, Y increases. So the answer choice here is going to be answer choice A, relationships, kids. All right, problem number 10 is a tricky yikes problem, and I'll show you how I'm going to work with this one. I usually label it, okay, because they're asking you a bunch of different things, and instead of reading back and forth, you just take the info and then label the chart. So first thing we want to do is underline what's important. It says, does the data in figure 1, right, figure 1, support the conclusion that infected monarchs tend to come from southern latitudes? Right away, we need to find southern latitudes. When you look down over here in figure 1, it doesn't say anything about southern or northern latitudes. So that's where we have to go back up here, find where it talks about latitudes, all right? So in this pink area here on the second line, it says northern latitudes down over here, and this is what it says. It says a higher delta squared hydrogen value indicates the butterflies originated from latitudes from the north. Okay, so now what I do is I see that here we're talking about the delta squared hydrogen, and the higher value means it's from the north. So right here, I just put N. I'm just taking this info up here and I'm labeling the chart instead of reading back and forth and getting confused. So that means now the lower value is going to mean they traveled further, less distance. So this would be from the south. Now, once I've taken this information, which is a yikes, I've simply placed it in here, and now I'm able to reread the question and then work with it. So this is the north, and this is the south. Let's reread the question up here again. Does the data from figure 1 support the conclusion that infected monarchs tend to originate from the south? So if you look over here, unaffected versus affected, remember the higher this is means they come from the north. So does it suggest that the lower value comes from the south? Yes, the correct answer is yes. So let's go ahead and cross out the 2 no's. All right, once we have 2 answer choices down, we've knocked out the no's. Now we have to find the difference between the 2 remaining choices, F and G. F says yes because the infected have a lower, and G says yes, the infected has a higher. Now, let's simply just go right back down over here, and here you see that we have the infected and the uninfected. So once again, here is the northern site 1. Here is the southern site 1. So you can see that here in the infected have a lower than site 1. So the correct answer choice here is going to lead you up here to the lower value, which is going to be answer choice A. Kids, the takeaway from this is it's a yikes problem. You cannot answer the question by simply underlining and pointing. You got to take information from the text area and actually physically place it into the graph or the chart so you can actually see it, because there's symbols, there's things that you need to know that are not in there. That's the whole trap on this test. It's a tough problem. The correct answer for 10 is F. Kids, problem number 11, it's another yikes problem. My recommendation is if this explanation is not good enough for you, please go back and listen to the explanation for problem number 7 previously. All right, 11. It says a scientist in Mexico captured monarch butterflies with a wing area of 690 millimeters squared. Based on the data in figure 1 and 2, which of the following conclusions can most likely be made? What I did is I started with the question itself. Based on the data, which of the following conclusions can be made? And we've got these wing area monarchs at 690, all right? First thing I did is I came down over here to figure 2, then I found where 690 was, all right? So 690, the wing area is going to be this x-axis. Here's 690 right here, okay? If you look at 690, you're going to see that this 690 is lower on the scale here of the delta squared H value, all right? So you're going to see that the majority of them are lower, okay? Then when you look up here, you see that this is going to be in the unaffected region and the affected region, but this leads us all the way back up to the yikes area here in the pink. And the pink says a higher delta squared H value indicates they are from the northern area right here, which is something that we talked about here in problem number 10. All right, so that means that the higher value here is going to be from the north, okay? So here you see that this lower value is going to suggest that they are from the southern region. That's going to lead you to the answer choice over here for answer choice D, the southern region. Kids, D for problem 11. All right, 12. It's a pointer, kids. Scientists discovered a new overwintering area in Mexico for the butterflies. She finds that more than 20% of the population are infected, and we're trying to figure out which butterflies originated from that site. All right. So what we want to do is we want to try and find where do they talk about the percentages of the infected. So I come over here and I'm looking at this figure 1. Here it is delta squared H and infected versus uninfected. Nope. I come down to the next one. It talks about the delta squared H value and the wing area. Nope. And then I come over here, and here in figure 3, it says the proportion of infected, and it says the region. All right. Now the question, if you look at the answer choices are about the region here. So that's where we're going to find the answer over here. Now, when we do that, we just got oriented. Just orient yourself to where you're going to be looking, okay? Now, what we're going to do is we're going to find 20%. So over here on the y-axis, it says the proportion. We're going to find 20% here, and we're going to roughly go across here. It said more than 20%. So the correct answer here is going to come from the central that leads us to answer choice G for problem 12. Problem number 13, it's a yikes problem. First thing we want to do is read and underline. Does the data from the study support the claim that unaffected monarchs have a higher delta squared hydrogen value than infected monarchs because overall infection rates are lower in the northern regions? All right, so a couple things here. First thing we're going to do is we're going to underline what's important here. I underline northern regions. The second thing is unaffected monarchs and have a higher delta squared hydrogen. All right, so right away I highlighted this in orange on my sheet, northern regions. So I came over here, and I remember from the previous question that we're dealing with the regions. Remember over here it says region. So I'm looking in this area right here for regions. Okay, and I'm looking at the northern region. So let's look. The northern region is over here. Now, when I reread the question, it says, does the study show the claim that unaffected monarchs have a higher delta squared hydrogen value of the monarchs? Overall rates is it lower in the northern regions? So if you look over here, here's the northern region, and you see that the southern region here is a little bit lower, and that the maximum is coming from the central up here. Okay, so right away I'm going to say no based upon that. So let's cross out the yeses. Then what's the difference between the two answer choices that are remaining, C and D? C says no because figure 2 shows monarchs with larger wings that originate from the northern. So let's go over to figure 2. And in figure 2 over here, it looks like we've got the wing regions, and we're looking in here to try and see we've got our delta squared hydrogen, and it looks like the higher the hydrogen is coming from over here, and it's got the wing area. I feel like that doesn't really, that's confusing. I don't feel like that answers the question. So then we go to answer choice D. It says figure 3 shows that the overall infection rates are roughly equal in the southern and the northern regions. So let's go ahead and look at the southern and the northern regions. Southern is here and northern is here. All right, so that is true. They're roughly the same. If you look over here, just slightly higher in the southern. I'm going to go with answer choice D. Now, if you're struggling with this problem and it doesn't make 100% to you based upon my explanation, I would recommend you coming back over here and getting familiar with the gist of this passage, which is at the very end of this first mini paragraph over here, which kind of gives you the full explanation of really what's going on in the experiment. It's telling you that the greater the distance, the higher the delta squared hydrogen value is over here. This will give you some more insight into the answer choice on that one. Kids, it's a tough passage. Just remember, you need the yikes for a lot of these questions. Passage number 3, problem number 14. Which of the following hypothesis asserts that cell fusion takes place during meiosis in whiptail lizards? Underline what's important. Cell fusion here, I underlined it in green. This is a yikes problem or finger scanning. You want to simply find that, and it's going to be in multiple places. I found it here in hypothesis 1 on line 4, and I found it in hypothesis 2 on line 6. 1, 2, 3, 4, 5. Line 6 here. That's going to lead you to the correct answer, answer choice H. Problem number 14, it says, which of the following hypothesis, if any, asserts DNA replication occurs after interphase? So potentially could be a prior knowledge questions if you've had this in, I'm sure you've had it already in biology, but if not, the answer can be found in here. What we do in problem number 15 is underline what's important. Here we have interphase and DNA replication, all right? So what I did is I found this one here, interphase, up here, and I simply looked in figure 1. Then in the interphase stage here, I looked over here and I saw that we have 46 going to 92, so that's going to double. And then we've got 46 going to 92 here, and then we've got 46, 92, and 184. I potentially could have been a little confused, so then I came over here and I yikesed out and I finger scanned for DNA replication over here. In this area here on the bottom of that second paragraph right in here, it talks about DNA replication. It says you're making an exact copy of the cell's DNA. All right, so here 46 times 2 is 92. 46 times 2, replicating it again, gives you 92. And 46 times 2 gives you 92. and 92 times 2 gives you 184. All right, so that helps you with that, with the interphase. But the question doesn't ask us about that. It says, which hypothesis, if any, asserts DNA replication occurs after? Do you see that word over here? The word after interphase. That means over here. Now, that means that we're going to basically double what we have. Over here, we've got this, but it actually splits. And here we have 184, so 184 times 2 is not what you see here. So that's incorrect. And then over here, you've got 92, and it's not replicating, it's actually dividing here. And then over here in hypothesis 1, it's 92, and then it's breaking down. It's not replicating. So in this particular answer choice, D is going to be the correct answer. None of the hypothesis on that one. It's a yikes problems, kid. All right, practice problem number 16, based on hypothesis 3. We're looking for which graph depicts the number of chromosomes in meiosis 2. All right, so we go ahead and underline hypothesis 3. We find that over here in figure number 1. And then we're looking for hypothesis 3. So over here it says that we have, in this particular phase here, we have 46, 92, 84. All right, so we want to start out at 46. And you see that all of these graphs over here do start out at 46. All right, check. If one didn't, you'd be able to cross that one out. All right, second thing is we're going to go from 46 to 92. So here is our 92. Here is our 92 up here. Does do that. And 92 works over here. And 92 is going to work over here as well. All right. Then we go over to 184. And then we look at the top 184, 184, 184. Looks good so far. Now, when we come back over here, you see that we're going to drop over into meiosis 1. And meiosis 1 tells us that we're going to go down and drop down to 92. So if you look over here, we drop down to 92 here. And over here, it says in answer choice H, we drop at 138. That's not what we see over here because we're not doing that, okay? Then over here in answer choice J, when we drop down over here to 92, you see in J, there is no drop level here, so that one can be crossed out. So we're basically left with answer choice F, and we're left with answer choice G. Then if you look over here, we're going to drop over here in meiosis 2 to 46 gametes, and then you got to find the one that goes to 46. So down over here, you're going to see in this one, it drops over to 46, whereas here it just leaves off. G is going to be the answer. Basically, you're just trying to transcribe your answer choices in from what you see in figure 1 and in this particular region here, which is going to be your hypothesis 3. 17, we're going to answer plug this one and just yikes out. So here's what it says: which of the following statements is consistent with all 3 hypotheses? Right away when you see that, that's yikesing. We look at our answer choices and start crossing stuff out. Here, answer choice 8 says whiptail meiosis produces 4 gametes. All right, so where do they talk about the gametes? The gametes is going to come from over here. So here it says meiosis produces 4 gametes. And is that true? 4 gametes over here in this one, there's not 4, so we can cross that one out. Get that out of there. Answer choice B, whiptail meiosis involves 2 rounds of cell division. So here, if you look up here, you're going to have the cell divide, and then you're going to have the cell divide again. So let's put a dot by that one. Answer choice C, it says whiptail meiosis involves 2 rounds of DNA replication. So DNA is just replicating itself. and that is not true. That's basic biological terminology, and so that one is out. Hopefully you can remember that. DNA only replicates once. Answer choice G, it says at the end of each phase, whiptail meiosis, cells present 46 chromosomes. If you look over here, is that true? At the end of meiosis, do we have 46 chromosomes? Up here, you have 92 and 92 on that one. Here, it doesn't say meiosis 1 or meiosis 2. Here is meiosis 1, so that is technically not true. We're going to have B for the correct answer on that one. Just use your answer choices and plug them in. Answer choice B for 17. Problem number 19, it's a long question, so what I do is I start by reading the actual question itself and then glance over and kind of get acclimated to what's going on. Here it says, what hypothesis or which hypothesis, if any, would predict that the cells present at this time would be able to produce a viable embryo? All right, so I know that I'm looking for something that's going to produce a viable embryo. So chances are this is going to be a yikes problem that's going to be coming from the mini intro in the upper left-hand corner. All right. So I noticed that this contains a lot of text because it's conflicting viewpoints. It's like hypothesis 1, 2, 3, but it's really a conflicting viewpoints passage. So we're going to use the same technique as the reading. In this case here, you see we have a pirate flag consequently. We have a pirate flag down over here that says however. All right. Now, we're almost yikesing out and looking for viable embryo. So if you look down over here, here it says right next to the pirate flag, however, viable embryo. It says, however, each whiptail gamete has 46 chromosomes, allowing it to divide into a viable embryo. So this is going to be the big picture for hypothesis 1, 2, and 3. So the answer on this one is quite simply hypothesis 1, 2, and 3, because we found it in the mini introductory paragraph in the beginning, which talks about all of them. How easy was that? Now notice we didn't even really need to read all of this stuff in order to answer the question. That's there as a distractor. When the question gets super long, the tendency for kids to remember and think about what the actual question is, by the time you get down here, you're not really paying attention anymore. So whenever the question is really long, for example, in the next 3 questions here, you'll see we'll do that again. Read the question itself first. Problem number 19, it's a really long question, so let's start off by reading the question itself. It says, a scientist observed a complete whiptail meiosis and discovered that it requires a total of 40 minutes. Which hypothesis resulted in this result? Okay, so we want to try and find out 40 minutes. Now, let's go back up here and read the question itself. It says, suppose round DNA replication requires 20 minutes, cell division 5 minutes, for cell fusion, I underline that, and 10 minutes. Okay, so this is the key word here. It says cell division and cell fusion. So I use these as a yikes. I went in and I tried to find where they talked about cell fusion and cell division. Here you see it says cell division and cell fusion, and over here it says cell division and cell fusion. All right, so now I know I'm in hypothesis 1 and hypothesis 2. If you look over here in the third one, it says cell division, but it does not say cell fusion. All right, so that's going to lead you to just hypothesis 1 and 2, which is going to give you answer choice C. See how we just, once we know what we're looking for division and fusion. And basically what you do is you just finger scan for those words. Keep in mind that the question when they're longer, if you can reword this in your own words and understanding the question is actually quite easy. Problem number 20, a long question, so let's read the question itself. Which of these subphases involves the formation of a nuclear envelope in the daughter cell and the splitting of the cytoplasm into two separate cells? Down over here, when you split into two separate cells, you should recognize this as the final stage of cell division. You've got one cell, it starts getting globulated, and then it breaks off into two cells. All right, so when we go up here and we read the new information, it gives you that right there. It says there's 4 subphases in meiosis 1. Prophase, which is the first phase, metaphase, anaphase, and telophase. Telophase is the last stage, which would be a Scooby-Doo synonym for final. So the answer on that one is going to be J, just using a little bit of kid logic. All right, practice problem 21 is a little bit tricky with the wording. It's a yikes problem here. It says, in experiment 1, as the test weight increased, the balance position of the meter stick does what? Underline what's important. We're in experiment 1 and we're looking for the test weight. So go over here, find where experiment 1 is. Experiment 1 is down over here. And now you see here is the diagram. All right. When you look at the diagram here, you see that there is a 30 Newton weight here, but that's not the weight that they're talking about. They're talking about the test weight. The test weight is here. So if we're balanced here with a 30 Newton weight here, and we have our test weight here, this is the fulcrum that's going to be in the middle that's going to balance between. So if our weight here is balanced with this 30 fulcrum, at the fulcrum with the 30 Newton weight here, if we were to increase this weight, you would see that the scale would actually tip down. So what we're going to need to do is we're going to need to move the scale stick over, and that moving it over would move it over to the left. All right, does that make sense? As this increases, it's going to overpower this 30 newtons and the balance is going to be off, and therefore you're going to have to move that over to the left. That's going to give you answer choice A. Just look at the diagram and try and figure it out. All right, in problem number 22, we're going to use the answer plug technique here. So we basically look at our answer choices, find the stuff inside the passage, point, and I'm going to be paying particular attention to the formulas. Here's the question: which of the following statements comparing experiment 1 and 2 is going to be false? Experiment 1 is here, and you see here is our fulcrum. That's the balancing part. Here is our measuring stick, and here is the weight. Over here, we've got the fulcrum again. We've got the balancing measuring stick, and then now we have the weights on either end. All right. Both of these positions here, we are going to try and balance the stick on the fulcrum. When we look at our answer choices here, you're going to see here it says experiment 1 used blocks of unknown weights. Well, is that true? If you go back in here, you're going to see that the blocks that we're using, if you finger scan, it tells us we have 30 and N. So we can go ahead and cross that one out because that's not necessarily true. Experiment 1 involved a fixed fulcrum position. Okay, so the fixed fulcrum position here, this is where it is, and we're changing the distance of this weight here. If you read in here, you're going to see that that also is incorrect. Answer choice H says 1 and 2 involved unequal torques. This is where we're going to have to go ahead and try and finger scan for the yikes word torque, all right? For right now, let's just check J. J says experiment 1 and 2 involved weights that generate equal torque on both sides of the fulcrum, okay? So torque, by definition, is over here in the pink. It says torque equals force times R, which is the measuring stick arm, all right? So if the arm is long and short, and then the force would be represented by the weights. So here, this particular answer choice says experiment 1 and 2 involved weights that generate equal torques. Well, that's true because what we want to do is we want to balance on the fulcrum. So that is going to be true. Now, when you come back over here and you look at H, just to spot check our work, we already know that's the correct answer, which is the one that's false. H says experiment 1 and 2 involved unequal torques on both sides of the fulcrum. Well, if the torque was unequal based upon what we see for our formula, it would not balance on the fulcrum. So the correct answer for 22 is going to be H. Problem 23, it says imagine a student were to perform experiment 2 on Mars, where the acceleration due to gravity was less, 3.7 meters per second squared. Would the results change? First thing we want to do is just go over here to experiment 2 and see what they're doing. Here we have our meter stick, we have our fulcrum, and we have some weights that are going to be balanced on both sides. Now think, whether it's increased gravity or decreased gravity, that's not going to have any effect to do with anything on the fulcrum and the balancing mechanism. You could take proportion, say that this is 10 newtons, and this is 100 newtons, just I'm making this up as we go. If I were to go 1 newton and 10 newtons and just do it proportionally, you see that the fulcrum would still be at the same position and still balance out. So it doesn't matter where the gravity is. In this case here, the answer is going to be no, so we can cross out answer choice A and B. C says no because the weights in the blocks would not change. Well, the weights in the blocks would not change, however, the effect would change. And D says no because the relationship between the weights and the blocks would not change. The relationship is the thing that would not change. The weight of the blocks, because of the gravity, is going to affect the force. And if you're not sure about that, you can come back over here. It's physics, kids. D is the correct answer for problem 23. Problem number 24, we're going to estimate where the chart leaves off and then look at our answer choices. Here in 24, suppose that the student had tested an additional block in experiment 1, and the position of that block had weighed 0.5675 meters. What would the block weigh? So let's go ahead and underline what's important. We're an additional block, experiment 1 and 5.675, all right? Here's experiment 1, and you're going to notice that experiment 1 does indeed entail table number 1, okay? So what we want to do is we want to take that number, 5.675, and we're going to drop it into the position. So I put it right here in the blue, okay? And then you can see that it's going to be, because of our arrow here, we have 10, 20, 30, 40, 50, 60 down here. You know that it's going to be bigger than 60. But if you look at this number right here, is it close to this number, the new number they give us, or is it way off? If it's way off, if it's a way smaller number, then you would see that the relationship would change. So this number here in 60 is 60 newtons in this column right here. You see that this number is 0.5750. So this is our new number is 5675. So you would see roughly, if you look at the differentiation between 50 and 60, you would see it's just basically one more unit. So 60 would roughly go down, and this number here in this column would be 70. Kids, don't forget that when you have charts of numbers like this, you always want to throw arrows in the charts so you understand the relationship. You're always going to shoot your arrowhead towards the large number. Here is the bullseye, 60, so we would draw your arrow here. The large number up here is where you would draw your arrowhead pointing that direction. In this particular case, the correct answer is going to be G for 24. Problem number 25, it's a tricky conceptual kind of a thing here. Let me show you what I did, all right? So first thing that we're gonna do in 25 is read the question, point, and then think. Based on the results in experiment 2, we'll underline that. What's the correct order of the 4 blocks from the largest to the smallest? Now let's go ahead and find experiment number 2. We come over here, here is experiment number 2, and here's the diagram. So we have the meter stick here. We have the fulcrum, which is the balancing part. And then you notice we have block A on the left, and then you have block B on the right. Just by looking at the diagram here, you see that because of all this space, that block B is exerting a force and block A is exerting a force. Both of these forces are the same, but block A is just block A and block B has all of this stuff here, including the stick arm. So you could assume that this block B is very light because the longer and more distance between the weight and the fulcrum will tell you that the block is going to be much lighter than the block on the left. So right away, you can put a star by block A as saying block A is quite heavy, okay? And block B is quite light. When you come over to the answer choices right away, you're going to be able to cross off answer choice B right away because block B is the lightest one. Now, you already know that block A is very, very, very heavy because there's not much distance between that and the fulcrum. Now, the next thing to do is to glance over here at table 2. If you look at table 2 and you compare block A, you see that if we were to get somewhere in the middle, block A with another block and get it as close to the middle, that means the fulcrum would be here, then that means that block A and the unknown block would be somewhat equal. All right, so here is block A, block A, block A. Now when you look down over here at block D, here it's 0.6 and here it's 0.42, okay? So we could cross this one out and we could say that block A is heavy. Here, block B, and block C and block D are also heavy. All right, so we already know that block A is heavy and block C and D are heavy. Now look at your answer choices. You have block A as being heavy because it's in the first position, and here you have block B being heavy. But that's not what we see over here. The other two options that we have as the heaviest blocks are C and D. So do you see how this block B here could be crossed out? We have two choices. We have block D is heavy and block C is heavy. Well, we don't have any representation between C and D except for down over here, but that's not the frame of reference that we have up top. Up top, we have block A. We want to use block A because that's the one that they've said already is pretty heavy. because of what we've seen here with the balance. All right, so block D and block A are next to each other like we talked about here. And you'll see that we're basically in the middle. The fulcrum would be at 0.6, which would be somewhere right over here. And you would have your block A and you would have your block D there. There's no real way to connect to try and find out if C and D are going to be heavier or not. Basically, if you looked at C and D, you're looking at 0.66. That doesn't give you a whole lot of information. The best way to do it is what we just saw. Look at block A over here on the fulcrum, next to the fulcrum where there's not a lot of space, and then see which one would be the next heaviest one. D is the answer for problem 25. Problem number 26, which of the following is correct units for torque in these experiments? What I did is I simply came over here to table number 1. I saw that in the units of weight, we're dealing with newtons, and the position is dealing with meters. So in order to calculate torque, you need to have both of those. It's going to be newtons times meters. That's going to give you answer choice G. Problem number 27, here it's a long question. Start by reading the question itself to get a very general idea of what's up. Here in the yellow it says, what effect, if any, would this have on the balance position of the various test weights in the experiment? So we want to see what's going to happen to the balance position. Okay, now I'm going to go ahead and read the rest of the question. We're trying to see what's going to affect the balance position. Here in experiment 1, we're going to exert a small force on the meter stick on the left side of the fulcrum. So that leads us over here to experiment 1. So here's our fulcrum. And we want to know what happens to the balance stick. So we're going to put a small force here. In essence, what they're saying is when we put force going up, we already have 30 newtons going down, the force is going down, we're going to exert an upward force. So really what this means is we're going to lighten the force over here. Well, that relates it back to what we've been doing already. If this force is less, then here you're going to see that this scale, the meter stick, is going to go up here. And in order to balance it again, we're going to have to push everything over to the left. So the correct answer here is going to be answer choice A. See what I did? I just kind of Scooby-Dooed it. All right. Problem 27 is A. Problem number 28, it's a yikes problem. According to the passage, it's the addition of a catalyst. Underline catalyst and then finger scan for it. Catalyst comes over here in the mini introductory paragraph. It's on line 3. It says catalysts lower the minimum amount of energy or the activation energy. The correct answer on that is going to be answer choice J. Yikes, kids. 28J. Problem 29, it's going to be a rearranger. Underline what's important so you make sure you go to the right area. It says, according to table 1, which of the following correctly ranks the catalysts from the smallest to the largest? All right, so let's go ahead and find table 1. All right, and we are looking for the smallest. So make sure that you are looking in the right area. So the smallest one over here is down over here is going to be 2.2, the sodium. But if you look at your answer choices, you see that the sodium is not in the answer choices as the smallest. So you got to go to the next one. So the next one up is going to be no catalyst, but that's not in the answer choices as well up here. So you go to the next one. The next one here is 4.3, and that's going to be the potassium. So that gives you answer choice A, keep. B says silver, so that's out, and D says silver. Okay, so we're left with answer choice A and C. Now, what's the second one after 4.3 when you look over here in trial number 1? The next one that you see over here is going to be the aluminum with 6.7. All right, and then you simply look at your answer choices here. You see that we've got aluminum chloride right here, and that's going to be aluminum chloride right here. C is the correct answer on that one for 29. All right, problem number 30, what this is this is an estimation question. They're giving you a new compound, platinum rhodium, all right? It's a catalyst. It's going to be more effective than the potassium. It's going to be less than vanadium, all right? So what I did is I just simply came over here and I found the values for each one. So potassium here, I said was 4.3, and then this one down over here, vanadium, is 9, all right? So I looked for an answer choice that's going to be between 4.3 and 9. You can see 3.8, that's going to be too low. And J is 10, that's not going to work. 4.0, that's still not going to fit in here. So the only one that's going to be in between 4.3 and 9 is going to be answer choice B. But you see what I did, kids, is I just took the values here, and I love just kind of label them off to the side so you can actually see it. H is the correct answer for 30. Problem number 31, tricky. The question says this: based on a student's results, which of the following reaction coordinates to the graph that represents with and without sodium? So you've got with sodium and without sodium. Remember, sodium is going to be a catalyst. All right, so if you look at your graphs over here, you're going to see that that leads you over to look at this, okay? Now, it's important for you to make sure you recognize that here it says uncatalyzed, and here it says catalyzed. Catalyzed means there's going to be some type of a condition or one of the reactions that's the catalyst to get it going, okay? So if you look at this, now if you just look over here, you're going to see that the dotted line is lower. So you're thinking right away that the answer choice is probably this one here. But we forgot that this question here, we're going to have to go with sodium and without sodium. So that leads us down to table number 1 down over here. So here we have sodium, and the value on sodium is 2.2. And then without a catalyst, right here, no catalyst, it's 3.2. So that means that this is going to be flipped around. This is what you see, but it's actually going to be flipped around. So the correct answer here, instead of having the dotted line lower, the dotted line is going to be above because of the values from table 1. And the only one that gives you that is answer choice A. Problem number 32, if you got this one wrong, chances are you read the question, misunderstood what they're asking you, all right? Read, calculate, reread, those are the ways that we're going to answer the question along with underlining stuff. Here it is. Suppose that a student wanted to run an uncatalyzed reaction in reverse from the product to the reactant according to figure 1 compared to the rate of the forward reaction. What is the rate of the reverse reaction? So here we're going to go over to figure 1. When you look at figure 1, you see that we've got reactants here, and it's like roughly right there. And then here's the product here, and it's roughly here. So right away you know that the product is lower than the reactant, okay? So here the question, let's read it again. It says according to figure 1 compared to the rate of the forward reaction, okay? The reverse reaction, it's going to be lower, right? So here we've got lower, and higher. We can cross out the first part with the highers. Okay, now we've got 2 choices that are remaining. It's F and H. Answer choice F says it's lower, and here's the reason. Because the EA is lower relative to the product than it is to the reactant, okay? And that is what's going on here versus lower because the EA is higher in regards to the product, okay? Now remember, here we have the product, and if we're going in the reverse direction, we're starting low and then we're going up to a higher level. Okay, now if you read the whole question, you're going to see it here. Suppose the student wanted to run the catalyst in reverse going from product to reactant. According to figure 1, compared to the rate of the forward reaction, the rate of the reverse reaction would be what? The rate of the reverse reaction is going to be lower because the EA is higher relative to the product. Okay, so here they're referring back to here the reactant is going to be higher relative to the product, which is down over here. You see how we were only able to get to that understanding when we read it, broke it down, and then reread it one more formal time to come up with answer choice H. It's very, very tricky wording on that one. The correct answer, once again, you got to weed through it. It's H for 32. All right, kids, problem 33, if you got this one wrong, it's a prior knowledge one. We're going to just kind of think about this in a second, make it as easy as possible. It is prior knowledge, but I think you can use a little kid logic to fix it out, all right? Step 1 is make sure that you understand what the question is by reading the question itself. Here it says, which of the following intermolecular forces hold together sodium, fluorine, and sodium fluoride, okay? So you want to know which of it's going to hold them in there, all right? Now, problem 33's beginning part says the rate of chemical reaction depends in part of the nature of the intermolecular forces that hold atoms together in a molecule or a compound. Well, we already know that. That's basically just information that's repeated down here in the yellow, all right? So we're thinking of something that's going to hold two things together. Now, if we look at our answer choices here, you see that we have basically two things. It's fluoride and sodium. Sodium is table salt, and fluoride is something that comes in your toothpaste, okay? Obviously, you know that that stuff is not metallic, so that can be crossed out right away. Van der Waals bonds, that is something a little bit weird, and you should remember this from school and know that this is one of the weirder ways of bonding things together. So we could reduce it down to ionic and covalent, okay? So just think like a kid. Covalent, cooperation, coexist. Co, means to share. An ion is something that actually mixes, all right? So here, if you think, we've got this sodium fluoride. Is that sharing, or is sodium mixed with sodium fluoride and to produce the sodium fluoride, all right? So here, ionic bond, because an ion is really just something that's mixed. When you look at the name sodium fluoride, you should be able to derive sodium fluoride as a mixture of sodium and fluoride. So we're going to get A for the answer on that one. It is a prior knowledge question. It's not inside the passage. However, we can use a little bit of kid logic, and if you did remember any of this from our general chemistry class. Problem number 34, it says based on the results of study 1, what's the average life shift of star 3? So let's go ahead and take a look at study 1. Study 1 comes from up here, and you're going to see here it's going to lead us to figure 2 over here, and we're looking for star 3. So star 3 is right here. That's the black line, and that black line goes like this. And you see that we are in the negative down here. So if you were just to draw a line and find the average there, you see that the average is going to be in the negative area, and the only one that answer choice that's negative is going to be J here for that one. Problem number 35, based on the results of study 1, what is the approximate time it took for star 2 for the exoplanet to complete a full orbit? Okay, so first thing that we want to do here is we want to go to study 1. Study 1 is up here. Then what we want to do is we want to come over here and find star 2. All right, here you're going to see that star 2 is this dashed line, and that's going to refer you down over here. Okay, so now what we want to do is we see that we start here, we go down, and we come back up here. So that's from start to finish. If you look over here, that's going to be 3 years. The correct answer here is going to be answer choice B, 3 years. Problem number 36, based on the results of study 2, what's the order of the 3 stars from the stars with the fewest exoplanets to the most exoplanets? Okay, so first of all, let's go ahead and find study 2. Study 2 is here. And in the text area here, it gives you some information. It says there's a pirate flag thus, all right? And then it gives you your stars here, star 1, star 2, star 3. And then also you see a pirate flag down over here. So what it says here in the first one, star 1, it says star 1 maintains a relatively constant brightness over time. So that tells you there's very few exoplanets. All right, so this is kind of turning into a yikes. Right away, you can go ahead and you can cross out some of the answer choices. For example, you could cross out answer choice J, and you could cross out answer choice H. Now, we have answer choice F and G. Star 1, star 2, star 3, star 3, and star 2. Now we look at the second sentence here. It says star 2's brightness diminishes once every 3 years. Okay, and then here's our pirate flag. It says star 3 varies irregularly, but frequently. So frequently, it would be star 1, and then it would be star 2, and then star 3 for the answer choice on that one. All right, because we're maintaining every 3 years frequently in star 2, but it varies, and it varies frequently. It doesn't show up frequently, it varies frequently. So the correct answer, be careful here, kids, it's answer choice F. Problem number 37, it's a long question, so I usually start with the bottom here, and highlighted in yellow it says, the researchers found that light from the star was becoming increasingly blue at a constant rate, okay? Which of the following hypothesis would explain this, okay? So we've got blue, so I'm thinking, where's blue? Then I just kind of glance over here and I see we've got this blue shift right over here, so that kind of leads me to figure 2 as I kind of glance over, shifting light. All right, now I'm going to go back and I'm going to read the rest of the question. See how I just read and then glanced? All right, suppose an additional star from Andromeda Galaxy had been observed using the light shift method over the 6-year period. So there's a 6-year period here, right? All right. And then we want to try and look at that. Now, 6 years, then I come over here and I'm like, okay, so I'm still in figure 2, and I notice that we've got our 6-year period here. You've got your 3, 4, 5. So this is your 6-year period. Now it's time to answer plug. When we go in our answer choices here, we already know that a star that's an exoplanet is something that orbits something other than the sun. So shifting, that doesn't make any sense. So that's flat out off topic. A supernova is a giant star that's like super hot, and that doesn't have anything to do with what they're talking about here. So that's off topic as well. We're left with answer choice A and B. And A says the star is orbited by several exoplanets. But wait, it says that the light here is constant. Do you see here? So if the light is constant, then exoplanets, if there's several of them, there would be stuff kind of coming in and out. So that doesn't make any sense. Answer choice B says the star is orbited by exoplanets that have a long orbital period. Long orbital is a Scooby-Doo synonym for 6 years. And then also that is what we see there. The correct answer for problem number 37 is going to be B. Problem number 38, it's a yikes problem. It says, which of the following types of exoplanets is easier to observe using both the light shift and the transit method? What we want to do is we want to go over and quickly review the light shift method here. And basically what we see here is the light shift method is a study where there's unknown stars in Andromeda, and they basically shift towards the blue if it's coming toward you and shift red if it's going away, okay? In study 2, that's the transit method here. And basically what this is you're going to have between the sun and our planet, there's going to be like a small little blurb because that kind of like goes in front of you. It's like an eclipse almost, basically, is what it is. So that exoplanet, you'll be able to see like a little blurb as it goes by, okay? So which one is going to be easier to observe, all right? So light shifting or a blurb. When we look at our answer choices here, I'm going to sub-genius map here. It says answer choice F, small planets versus large planets. Now, if we're just thinking about the transit method, the transit method says if something goes in front, there'll be a little blurb. But if there's something that's large that goes in front, like a large eclipse, that's probably going to leave a larger blip. So between the two answer choices, I'm going to get rid of F because larger makes more sense. Answer choice H says gaseous planets. Gas doesn't really talk about anything from either one of them. And answer choice J talks about rocky planets. Rocky planets and gas are kind of a little bit off topic. So we've got light and then we've got basically eclipsing. So you can see these two choices are both basically off topic. G is the correct answer for 38. All right, classic ACT problem, kids. You're going to see here that this problem 39 here contains 1, 2, 3, 4, 5, 6, 7, 8, 9 lines of text. So our standard method is to start with the question itself at the bottom. It says, which of the following procedures would best help the science investigate this inference? Okay, so we're looking for how to investigate the inference. All right, now then we go back up. We don't know what the inference is, so we have to go back up here and read the rest of the stuff while we focus on what's important here. So here it is. It says the scientist performing scientist study 3, right, underline that, discovered an interstellar gas cloud, Earth, Andromeda galaxy, had a different molecular composition than the exoplanet, and the gas cloud had interfered with the absorption spectrum. So we have study 3, absorption spectrum. All right, so that's what we're looking for. There's something weird going on. So if we have the absorption spectrum, we know that we're going to have to deal with trying to figure out what's going on with the absorption spectrum. All right, so A, study 1 is light absorption, study 2 comes from the transit, and study 3 is our absorption spectrum over here. So I came over and I kind of just quickly understood what's going on here. We're determining the composition of the exoplanets orbiting the stars. All right, so if we're going to play around with the absorption spectrum, we should probably say that in the answer choices. We can also assume that something that talks about something about the other experiments is called wires crossed. So anything that says transient getting in the way or anything that talks about light shifting, that's the wrong experiment. So when we come over here, we see red shifting. So red shifting is wires crossed. That comes from the wrong experiment. That comes from study number 1. So I got rid of that one, okay? Answer choice B says repeating the experiment 10 times. Why would you do that? That just seems dumb. Answer choice C says compare the absorption spectrum. That's what the actual question is asking us about. And it's coming from study 3, so I put a dot by it. And then answer choice D says using a telescope with better resolution. A telescope is off topic. We never really talked about that, but the closest thing to a telescope would be the transient method, so we could actually see which one of those exoplanets is kind of coming in front of the other planet. So this also not only is off topic, it's probably coming from the wrong experiment, and I call that wires crossed. C is the correct answer on that one. So you see, it's important for us to weed through what's important and what's not. Problem number 40, if you got this one wrong, here's what it says. Based on the results of study 3 and the absorption spectrum below, which of the following gases is not present in the atmosphere of the possible exoplanet for star 2? All right, a couple things here. First of all, you can answer the question flat out from the question here. It says gases, and then you just look and see which one's a gas. So answer choice F says hydrogen, that's a gas. Nitrogen is a gas. Helium is a gas. Sodium is salt, like table salt. That is not a gas. We're looking for the one that does not make sense. Answer choice J is the correct answer. Kids, thanks for watching the review. See you in the next video.